So what are we talking about with a confidence interval? What is actually this thing we're looking to calculate? Here's kind of the definition of a point estimate versus an interval estimate. And what we've been doing so far is pretty much doing point estimates, getting a single value to describe a population, right? Taking a sample, calculating a statistic, your point estimate, your X bar, for example. Right, for the mu, the population mean, trying to estimate what the population mean is. That's what we've been doing. Now what we're going to learn how to do is convert our data, our statistics, into a point estimate, or sorry, an interval estimate, a range of values of good estimates, like a low and a high. And the way we're going to do that is taking your X bar, your point estimate, and plus or minus in that in general with 2 standard deviations. That's kind of a good estimate to get an interval. Now we're going to have more precise techniques to do this, but that's the idea. So we've been doing confidence intervals already in a general way, right, by looking at 2 standard deviations, but we'll look at something a little bit different here, look at more exact and more specific. To create a confidence interval, we're going to have a formula to do that. And to do that before, though, we need to specify 2 things, right? We need to know what the interval estimate is, which is the range of value, and at what confidence, right? At what confidence level, or what's our confidence interval we have, right? We'll talk about this term confidence level right now. And so the confidence level, right, interval or confidence level, really what we're looking at here, okay? A confidence level here is the success rate of the procedure used to construct the interval. So we're going to give you a procedure, right? And you'll see down here below the formula we have here to do that. And so, for example, if we ask you to construct a 90% confidence interval, right, then that means 90% of all the possible samples of the size that we're taking will produce an interval that contains the parameter. Now, again, that sounds very technical, and until we kind of do this, you'll have a better idea of what that means. So you're going to end up coming back to this description here, right? This also means that 10% of the time, our interval would fail to capture the true parameter, and so that we call it the alpha level of 0.10. It's kind of, again, the complement rule. We're 90% confident that the estimate I give you actually contains the population parameter. And if we're 90% confident about something, we're 10% confident. We have 10% not confident, if you think about that, in terms of confidence levels. And so let's take a visual of this situation here. Suppose 27.5% of some population are college graduates. Let's say we know that, okay? But let's assume we don't know this, okay? That's the truth, but we don't know it. And we sample 200 people to estimate that, estimate how many people in the population. So the idea is, again, in the real world, we don't know what the population parameter is, okay? But let's say hypothetically we don't know it, but it is 27.5%. So what would happen if I sample 200 people from there, right? If I sample 1 person from that 200 people, I actually get, you get a certain statistic, right? You're going to get a proportion, a sample proportion. And every time I sample 200 people from the population, I get a different value. You can see they start to pop up, right? Because they're not all going to be exactly 27.5%. The first one was actually. But notice how the distribution spreads out as I keep sampling 200 people from the population. A sampling distribution is being built. And so we end up generating, let's say, what I have here is a total of, let's say we get a total of 200 samples, right? And so now here are 200 samples out here. You will then see a certain percentage of them are all within a certain range. We have some outliers here, and some out here, but most of them are within a range here. And so that's the idea. We're going to look at the sampling distribution to help us calculate a usual amount, right? 95% of the values fall within 2 values, which would be a question we've asked you before as we create. So that's what a confidence interval is, and that's what we're looking at here as you build. To build it here, here's the exact formula we're going to use. It's your point estimate plus or minus, which is the statistic, some critical value times the standard deviation of the statistic, which is your based off your sampling distribution. And so it's your point estimate plus or minus your margin of error, because you're going to have a low value, a lower bound, and an upper bound. Now, in the next video, we'll show you how to calculate this, what we call critical value. That's going to be dependent upon what level of confidence we have, right? Your confidence interval. That's what's going to help us determine that.